This is the respiratory system, and pictured here are the organs that make up the respiratory tract. This is the pathway in which air flows in and out of the body, which is known as respiration. The air can enter the body in two ways, either the oral or nasal cavity. If the air enters in the nasal cavity, it will pass through the guard hairs and then the nasal conchae. These are lined with mucus to help trap dust particles or pathogens from entering the body. The nasal cavity also humidifies and warms the air so it is cleansed as it enters into the body. Then air flows into the pharynx. The pharynx can be broken into three regions: the nasopharynx epithelium, which is lined with to allow air to pass through, and then there's the oropharynx and laryngopharynx. Both the oral and laryngopharynx contain stratified epithelium, which is more dense and rough to allow for food and air to pass through. Then the air will pass through the trachea. The trachea is made up of hyaline cartilage in a C shape to allow for a sturdy structure, but also allowing for a bolus of food to pass through the esophagus without blocking the airway. In the trachea, there is also a mucociliary escalator. This is composed of mucus-secreting goblet cells and ciliated cells to create an upwards beating motion to excrete any debris that has been breathed in. It will go up towards the pharynx and then be swallowed in the esophagus, so it will no longer be in the airway. The air then leads into the main bronchus and lobal bronchus. These structures make up what is known as the bronchial tree. Then continuing, the air would flow through the segmental bronchus and bronchiole, and then the terminal bronchiole. From the nasal cavity to this point, the terminal bronchiole, this division of the respiratory system is known as the conducting division. Then the respiratory division begins, which is the remaining part of the tree where gas exchange occurs. The air will flow through the respiratory bronchioles, alveolar duct, atrium, and then the alveolus. These structures have alveoli lined within the walls, or are alveoli, which allows for the gas exchange to occur. Once the gas exchange has happened, the air will flow back through the way it came, exiting either the nasal cavity or oral cavity. Here are some students that will further discuss other aspects of the respiratory system.
Great job, class. Just take a second. Breathe, meditate.
What does this deep breathing do? Like, what's going on when we deep breathe? I've never really thought about it before.
Well, it's like your max inspiratory, so when you breathe all the way in, and when you breathe out through your mouth, it's max expiratory. So basically, when you're breathing in, you're not only using your diaphragm, but you're also using your sternocleidomastoid muscle, your scalenes, your external intercostals, as well as erector spinae. So you can really increase that volume and get all that air in.
And then when you expirate air, it's probably like your abdominals then.
Yeah,
right?
Because they're pushing down,
And
and your as well as your external intercostals pushing down to create more pressure, so the air can come out faster. So that's why you go.
And then your diaphragm, that's in both. So when you
Yes.
inhale air, is it like this or is it flat?
So when you inhale, it means your diaphragm's contracting. So when it's relaxed, it's curved like this. But when you contract, it flattens out to increase the volume in your thoracic cage to lower the pressure. And that means air can flow into your body. So that's why you're getting air flowing in. When you expire, it's going to come back up. And so it decreases the volume, which increases the pressure in your thoracic cavity and pushes the air out. Because air moves from high to low concentration.
Oh, I didn't know that. I didn't know this deep breathing had like actual meaning. I thought
That
he
really helps
was
you.
just saying it.
I know, right?
It's crazy. What if you exhale a lot of air? Like,
Well, that's called hyperventilation.
oh yeah, oh my gosh, I've had that before. I got really nervous and I was breathing out a lot of air. And then they gave me a paper bag to like calm me down.
Right, to get some of that CO2 back, right?
Yeah. So you just have a max CO2 going out when you're breathing basically a lot.
Oh my gosh,
right?
swimmers do that sometimes. Like,
Aren't you
so
a
they can
swimmer?
hold their breath. I mean, yeah, sometimes. But it's
Do you
not
do
really
that?
No, it's not really good for you.
Oh.
Because you can do this thing called shallow water blackout, which is where you reach the max and you don't realize it, and then you just
The
pass
max
out.
CO2 levels?
Yeah, so then you pass out
Oh.
underwater, and then it's
That
not
would be
good.
scary.
It would be.
But, so that's just max CO2 going out, some hyperventilation. Wow. I didn't know breathing was like, I don't even think about it. Like, it's,
I know,
I'm
right? It's
just
just so
sitting.
normal.
and it just comes so naturally. Huh.
I mean, like, just when you're sitting here and just doing quiet breathing, it's also known as tidal breathing. So it's just the amount of air you're breathing in and out normally when you're just taking a breath. So you don't even
And
have
you're
to
not
think
even
about that.
using all your muscles, right?
Only the diaphragm.
Oh.
And then you're able to exhale because it doesn't even use muscles. Because your
Really?
lungs are so elastic, the air just like, so you stretch and they have to recoil. So then the air just flows out and then out and in. And it's just, you sit here and like you don't even have to think about it because your brain just
You're
controls
right.
the whole
I
thing.
never think about
I know,
it.
right?
Unless, when I'm crying, I'm a mess. I just,
Oh my gosh,
I
yeah.
swear my brain's just like, it's so,
Yeah, it's
so
the
many
limbic
emotions.
system in the brain, so when you're like crying, when you're angry, any
Yeah.
emotions can influence how you breathe. The rate at which you breathe, how
Or
much
when
you
you're
breathe.
exercising, like we said,
Oh,
swimming.
yeah.
Like when I go running, I know I breathe obviously a lot more. So then I'm probably using like that max expiratory reserves
Yeah.
and inspiratory reserves, right?
Mm-hmm. You're trying to get as much air in and out and stuff.
So when I do that, does all the air go out?
No, actually it doesn't. There's a little bit
Really?
left that's
'Cause
called
I feel like
residual
I'm-
volume. I know, you
I
always
feel like
you're
I'm
breathing
like getting it
everything
all out. So it's residual volume?
Yeah. So you just have a little left every time, every breathing cycle,
Oh.
because you can't physically blow everything out.
Wow. Interesting. Didn't know the air flowed so much in and out in my
Yeah.
body.
It's a really complicated process, but it's really cool. It's kind of necessary for life, so I'm glad we do
Breathing
it.
is important.
Yeah.
I know what's happening right now. I learned it in class the other day. Your diaphragm is spazzing because you probably know, is hiccups, right? Yeah. People say you can scare them away, and that is because you take a big breath and you're expanding your diaphragm. Because right now, your diaphragm's spazzing and it's going crazy. And when you suck in that air, it's going to go over your vocal, like your vocal box, your voice box, and it's basically backwards speaking. So just take some deep breaths, because I'm not going to scare you. Probably couldn't. And just let your diaphragm expand and just stretch out. Because right now it's like, you know? And so when you do that, the air is just going backwards, and it's so confused. So just take some breaths, like we learned in yoga, some deep breaths, and it should go away, you know, in a few moments.
Hey,
They're working?
I think so. I don't have hiccups
Next time you have
anymore.
the hiccups, think about it. It's actually interesting. But all right,
Thank you.
yeah, no problem. Whoa,
Bless you.
thanks. It must be allergy season.
Or I
My
mean,
nose is just like stuffy.
you're sneezing. We learned about that in
Yeah.
class. So,
Oh, yeah, we did.
yeah, we did. So basically, sneezing is just like forced expiration, meaning your body is just trying to get rid of like particles or dust or anything that's stuck in your respiratory tract. So the pressure just builds up, and then you're able to expel all that air through a sneeze.
Oh, so that's why I go.
Yep.
Well, I didn't do it that time, but sometimes if I
Sometimes
got
you
a
get
big
really big
sneeze coming, I'm just
sneeze.
like, achoo, and it's everywhere.
Yeah. Same thing with coughing.
Really?
It's
There's
just
the
like-
same thing?
Yeah, it's just like on a smaller scale, but it's forced. Another example of forced expiration.
Oh.
So
So this one's like the upper respiratory, and
Yes.
a cough would be like the lower,
lower
respiratory.
respiratory. Yeah, and it's the same purpose, just to clear out the respiratory tract.
Hmm. You know, speaking of respiratory tract, what about smokers? Like, I see people around campus smoking all the time.
So disgusting.
And
It
I hear them
ruins
coughing.
their lungs, and especially this thing in your trachea called your mucociliary escalator,
Uh-huh.
which basically is mechanism in your lungs that takes the mucus that's produced, and it, like, the cilia moves it up out to your nasal cavity and your pharynx so that you can cough it out. So mucus.
So it's like moving up like an escalator.
Yeah,
right?
but then in smokers, the cilia, all the smoke and the chemicals and stuff, the cilia get damaged. So the escalator doesn't work as well, so then you're more prone to infections, you're coughing a lot because you're trying to get all that out.
Stuck, huh? 'Cause
Yeah.
it's not coming out.
Definitely. So don't
No.
smoke. It's gross.
Probably a good idea.
Smokers' lungs are black and they're just...
No way.
They're
You know,
super nice and
I bet their compliance, their lung compliance is messed up too, because compliance is like when your lungs are able to stretch.
How
And-
stretch they can breathe.
And if you like scar your lungs, they probably won't stretch as well, right?
No, they have a harder time to breathe. They have a larger resistance, so they have to breathe harder to get the same oxygen content
They
in
get
and
the
out.
same flow in though, right? The same amount of
Yeah,
air, but
yeah.
they just can't expel it as well.
Yep.
It's probably more hard when they like try to exercise, I bet, because you have to use your forced expiration and your inspiratory expiration reserves.
So they wouldn't like
Probably
yoga.
No. Yoga's a lot of breathing.
It is.
Okay. Anything else? We good?
Okay. All of this breathing stuff reminds me of all like gas exchange we talked about in class.
Oh, I remember Todd talking about that.
Yeah, like the pressures and the capillaries and all of the systemic stuff, all those changes. We should definitely look into that some more.
Yeah.
So class, let's begin our discussion today on gas exchange through the respiratory system. Where I'd like to start is talking about pressure gradients and their influence on this type of gas exchange, and how atmospheric pressure plays a role in the movement of air through our bodies and out back into the environment. So I'd like to start with atmospheric pressure. Now we all know atmospheric pressure is 760 millimeters of mercury, and 760 millimeters of mercury we can also say is 1 atmosphere of pressure near Earth. So that is the air that we breathe. That's the pressure of the air that we breathe. Now there are 4 main gases that we like to talk about in the pressure that in the air that we breathe, right? That's nitrogen, oxygen, water in the form of vapor, and we have carbon dioxide. So those 4 are going to make up the air that we breathe. Now, nitrogen is going to comprise most of our air, and it's about, if you were to break it down, 600 millimeters of mercury, around there, in terms of the partial pressure in the air. Oxygen is going to be about 159, you can see, 159 millimeters of mercury in the air. That's its partial pressure. Water vapor is going to be about 4 millimeters of mercury in the air. And then we have the partial pressure of carbon dioxide, which is going to be about 0.3 of a millimeter of mercury in the air. So a lot more oxygen than there is carbon dioxide in the air. And those are really the 2 gases that we're going to be focusing on when we talk about the respiratory system and gas exchange through our body. So, like we said, 159 millimeters of mercury oxygen in the ambient or atmospheric air. Partial pressure of carbon dioxide is about 0.3 millimeters of mercury in the air. Those 2 particular pressures are going to change respectively when they enter your body. We see a drop in the pressure of oxygen and an increase, huge increase, in the pressure of carbon dioxide. And as that pressure is moving through its gradient, it's going to go from 104 millimeters of mercury of oxygen in the lungs to 40 millimeters of mercury of oxygen in the tissue. So that pressure gradient right there, the difference between the pressure of oxygen in the lungs and the difference of pressure in oxygen in the tissue, is what's going to allow oxygen to move from your lungs into your tissue so you can utilize it for nutrient absorption, all the metabolic processes that oxygen aids in, right? So that's the pressure gradient of just oxygen. Now if we break down carbon dioxide here, we want to expire carbon dioxide. So the pressure is lower in the lungs, carbon dioxide, relative to the pressure in the tissues. Because the air is always going to move from high pressure to low pressure. So carbon dioxide in the tissue is going to move out of the tissue and back into the lungs, where it's going to be expired, and you're going to have this whole net flow of gases through the body. So I hope that makes sense. I hope it sheds a little bit of light on how air moves through. It always moves from high to low pressure. We see it with oxygen here. We want oxygen in the body, so it's going to go high pressure to low pressure. And then to move carbon dioxide out, it's going to go also high pressure to low pressure from the tissues to the lungs, out of the body.
Wow. Now I'm going to think about all the processes that happen in my respiratory system.